Everybody. Welcome to Big MiniConf today. My name's Yan. I'm one of the co-founders of Code Chrysalis, and we are so excited to have you here today. We've got actually two tracks of speakers, track A, and you are right now in track B. And so first up, we have Sean, who's going to be talking about PWA. If you don't know what that is, it's a progressive web application, and he'll be getting started. Then at 1:30, we have encryption with Austin. At 2, we have Dart, Let's Play Dart with Yuri. And then last up to round out track B, we're going to have what is blockchain and how you can use it to help your business with Jimmy. Now I'm going to give some time for Sean. Do you want to share your screen? Make sure we can get everything started in time.
Hey, Jan, do you mind giving me access so I can share my screen?
You should be able to now.
How are we looking? I assume you can see my screen now?
Great, that looks wonderful. So Sean's going to be getting started right at 1 p.m. For those of you who, by the way, don't know about Code Chrysalis, we are a coding bootcamp based out of Tokyo. Right now we have our students who will be presenting today, of course. They are currently a little bit over halfway through our full stack software engineering program. And they'll be graduating actually end of September. And I'll be talking a little bit more about that throughout this event. Yeah, right now you guys are about halfway. All of these tech talks that you're seeing today are chosen by the students themselves. As instructors, we have very little, I guess, intervention in the topics that they choose. And so, Sean, I guess before we get started, why did you choose PWA out of?
It was actually before I joined the course. I got interested in mobile development alongside web development. And I was kind of doing React and React Native at the same time. And I thought to myself, well, if I can make a website mobile friendly, can I make it mobile friendly enough that I don't need to keep coding in React Native? The answer is obviously no, not really. But you can get pretty close with progressive web apps, and that's what got me really interested in it. And then I found that it had more to it than just the mobile side of things. So it kind of just spiraled off from there.
That's pretty cool. That's a very specific interest. I remember when you all were choosing topics, like yours came pretty fast. And so you knew what you wanted to do, which is really cool. Once again, after Sean, we've got talks on encryption, Dart, and blockchain. And this is just for track B. So if you're interested in track A also has really good stuff. So after Sean speaking, if you want to go check out the topics in track A, you can as well. We've got stuff on Unity, machine learning there, Anime.js, webhooks, and Docker after Sean speaks. And so, yeah, just a really crazy mix of different technologies, which is what we love about Big MiniConf. It's just a bunch of our students getting to choose whatever topics interest them. Sean, I think this is the first tech talk you're giving, right? First public tech talk.
We did one for Rakuten before, but I don't think that quite counts as a tech talk. We were doing it as a team, so it's my first solo one.
Wow. Okay, cool. Yeah, I think that's the same thing for everyone else as well. It's like their first solo tech talk. And so that's quite exciting. I think we can just about get started. So Sean, you want to take it away?
Well, as Jan said, this is Track B, and I'm Sean Darrett, and I'll be presenting progressive web apps. If you cannot decide which track you do want to watch, I do believe, and maybe Jan will correct me, that this is being uploaded to YouTube later. So if you are watching Track B and you'd like to watch Track A, you can move across later. Yeah, I'm getting a thumbs up, so that is correct. We'll move on with the slides. So let's just introduce myself to begin with. I'm a student at Code Chrysalis. I'm from England. I'm not originally from Japan, surprise. I'm also a hobby author, so I like to write sort of fantasy books in my spare time. On the right, or your left, depending on which way around you've mirrored your screen, is me and my wife on our wedding day. So that was a really good day for us. We got married in Japan at, yeah, we had a traditional Japanese wedding. So what are progressive web apps, and the real reason you're watching this? So progressive web apps, although I explained it a little bit before, I think the best way to explain it is that applications designed to work on any device, not just necessarily mobile, iPad, or web browsers and desktops, but the idea is that if you build a web app with this style of a progressive web app, is that it will work on any device, and it should feel like it's working, so like it's been designed for that native application. So if you are running your application on a mobile phone, on an application just for a phone or an iPad, and you design it specifically for that, using specific frameworks and languages that might be suited for that application, it's going to have much better capabilities, and web apps really can't compete in the kind of capabilities that they've all got. So progressive web apps trying to be the best of both. They're not as compatible with the native device as native apps will be, but they're very close, and they have a load of other advantages we'll be going through compared to native apps, and they have just as much range as web apps, because they are essentially just web apps, but with more capabilities built on top. So let's get, so one of those advantages of a web app is that the progressive web app compared to a normal web app is that it will continue to work even if it's offline. So if you've ever done mobile development, you know that you have to install the app. Normally, you would have to install the app to be able to use it, like something from the App Store or Play Store, depending on which device you have. You download it to your phone, and then you can use it. This is very similar to progressive web apps. You can access them on the internet like a normal web app, as you can see on the left-hand side with the yellow picture, where the application is running, it's connected to Wi-Fi. As you can see on the right-hand side with the blue picture, and the person might be on an airplane or somewhere else where they don't have Wi-Fi, the app continues to run because you can install the app. So what does this mean for businesses? It's quite an important question. So from the design point of view, do our customers actually need it? Will it grow our business, and is it feasible and robust? I'm hoping I can answer some of these questions in my next few slides. So although this is a lot of text, I'll give you some time to just sort of go through it. But just to cover it, essentially, what it's saying is Twitter, Nike, which is this Tokyo Stock Exchange, although it's not on here, also Hulu have tried progressive web apps, and they've seen a really large increase in people returning to their websites or pages or applications compared to when they were just running them as web apps or installable apps on the phone. Because they are able to install their web apps onto people's devices now, people are more likely to come back. Because they're coming back more often, they're seeing increases in sales, subscriptions, tweets, etc. So although that sounds really good to begin with, there are some downsides. So one of the downsides to begin with is that there is a kind of cost hidden behind it. So an SSL certificate, that costs about $400 to $100 a year. So for a business, it's not that much money, but your website should be running with one of these anyway. So what this would look like for your website is, if you take a look at the top address bar here, is that you can see that the address bar starts with HTTPS. This shows that the website is secure and is running an SSL certificate. With this, you know that your credentials are more safe. So if you're inputting a credit card, you should check at the very top to make sure that it has HTTPS at the starting address, That way you know that your credit card details are less likely to be stolen. It's not completely secure, but it's much better. Whereas if you look at the bottom one, it starts with HTTP. It's missing the S. It's not secure. So if you're typing in credit card details or any other personal information, and you notice that the website starts with HTTP, that is much less secure. So that's what the certificate will offer you, is much more security. So just relating back, so how the certificate links to progressive web apps. The whole point of progressive web apps is to make an app that will work across all devices. So it has to be secure. So from the user's point of view, however, what does this mean for them? Why do they want it? Why might your customer or persona, depends what you're working with, why would they actually need a progressive web app rather than two separate applications? So progressive web apps are fast, installable, reliable, and engaging. What you really need to be asking yourself as the product manager is our customer someone who needs our app to be installable? So if you are running, let's say, a shopping website, yeah, it's good enough reason. So you're running a shopping website and the customer is going through your website, checking out all the different things that they can buy. Well, they'll be adding them into the cart, but if they, for some reason, lose connection, or they're in an area with no connection, or they've gone camping, and the Wi-Fi is not great, or it just keeps cutting out, or there's no Wi-Fi at all, they will no longer be able to use your website. They don't have access to the internet. But with it being installable and working offline, they can continue to use your website, check things out. So if it's not a shopping app, it might be a photo app. So they can upload their photos to your app, which will queue up. And then when the internet is, when it's connected again back to the internet, the queue can make a push and push those photographs or your shopping cart over to the website, and then you can move and continue. So the idea behind that is that the customer always has access to your application rather than losing access and then probably losing interest later on. You want it to be reliable. That's kind of where we talked about the certificate, trying to keep it safe, to keep it reliable, keep it working, and to keep it engaging. Again, this is where we have that the customer is constantly able to access the application. So really what I'd like to do with you today, just for a quick demonstration, is go over how you might make your application a progressive web app. Because once you've got started, or you're just thinking about designing a web application, or you don't know whether you want to go with a web application and a native mobile app, or whether you want to try a progressive web app, you might not have started this before. As I did say before, this is an introduction. So I'd like to go over some of the tools you can use to test your web application, how to make a progressive web app. We don't have very long, as you can see. So the fact that I'm ready to show you how to build this just shows you how little time and effort you need to put in to go from having a web application that can only be accessed on the internet to a progressive web application, which will be mobile friendly, able to access on any sort of device, installable, and works offline. So these are really good advantages for something that takes a very short amount of time. So our first tool here is Google Lighthouse. Now, this can be found in the console in the developers tools on Google Chrome. It's completely free. You don't have to install anything. You just have to access the console like you would normally, and then you can run the automated tool for measuring the quality of your web application. So what I'd like to do is just head over and just sort of demo that on an application that I've made. So this particular demo is called the Date of Birth Finder. All it does is find the day that you were born if you put in your date of birth. That's not really what we're going to be concentrating on today. It doesn't matter what the application is. The point is that when it's done, if you look into a browser window, as you can see in this picture here, is there'll be a little plus sign, and it should be installable, so you can download it as a desktop application. And for mobile, that will come as a pop-up on the screen when you open it up and ask if you want to install it as an application on your mobile, very similar to if you downloaded something from some sort of website. So if we move over, this is the application in question. And if I just move Zoom out of the way, going to ignore everything inside of the actual application itself. What is in here does not matter. What we're going to be looking at is kind of this command console over here. So I believe I've already installed it. Yep, so if I've already installed it onto my desktop, so normally this will be a little plus sign, and it should come up asking you if you'd like to install it. And then it will appear as just a normal shortcut desktop icon on your background, and we should be able to load that. I'd just like to bring your attention over to Lighthouse. So this is just in the Developers tab. And the Lighthouse itself has many different things that it can run. So it's got the mobile and desktop, depending on which one you would like to test it against. I'm going to test it against the desktop this time, but if you'd like to test it against the mobile, just pop it into mobile mode, select mobile, and run it. So you can test the performance, the best practices, the accessibility, etc., etc. But what we're really going to be concentrating on today is the progressive web app side of it. So you can test whether your application works as a progressive web app. So if I just hit generate, it will run some tests on it. It will open and close it a few times, and then it will produce a small report just telling you how good of a progressive web app it is and some tips and information about how you can improve it. So it'll first test whether your application is fast and reliable. So these are the parameters it's expecting your application to have. So does the page respond really quickly? Is the start URL responding when it's offline? So it's come up green here, so it's showing that yes, these things are all correct. It doesn't have any advice for us. It does just have a small note on why this might be important. So is it installable? So it will check whether you can install this application. We've got all green, so this application here is installable. Now, is it optimized as a progressive web app? Is this the best it can be? Now, I've undone some of the code here so we can see what it looks like when you get some, I wouldn't say errors, but you can see where you should make improvements. So this one here is the content size work correctly for viewport. So this particular app might not work for mobile screens perfectly. So I have undone some of the viewport settings so that we could get this to appear, so that it gives you a little bit of kind of advice that maybe this isn't working for every device as it should be. And then down here, we've got a red one. So Manifest doesn't have a maskable icon. So if it appears red, it means that this is something you really should be fixing for it to be a progressive web app. So a maskable icon ensures that the image fills the entire shape without being letterboxed when installing the app on a device. So what this is telling me is that if I install this application on my device, if there's any images on this application, luckily for this application, there is no images, so this won't affect it at all. If there was images on this application, the actual image might not fill the entire shape, and it's not going to look as good as it should be, or it might stretch. The image might overrun the application space, and it'll end up with a scroll bar, so you have to scroll across, and it just won't work well once it's installed. Luckily, ours doesn't have an image, otherwise it would be a little strange to show it right now, but I just wanted to show you what it looks like when you have an error. So if we just move across to code itself, don't worry too much about what the application is made of. It's just a very simple CSS. There's an image in there for the icon, some normal JS and HTML. There's no frameworks in use. This is as bare bones of application as you can get. It's very simple. There's not much going on here. What we're going to look at is actually how to make this application progressive. So the first thing you're going to want is a web app manifest. You don't have to know what's in the code. You don't have to worry about memorizing it. It's a very short, simple Google away. And if you'd like to steal my web app manifest, feel free to do so. There will be a QR code at the end linking to this repository. The web app manifest itself, though, all it's doing is setting up some simple parameters for when it's running offline. So you can see you can set the background color at the top. I've set this to white. That will be the color that displays on the background of the desktop application when it's offline, while the information is loading. Before the CSS loads, that's what they will see. They will see a white background. You can set the display. I've gone with standalone, but you can change that if you'd like. Orientation is portrait. You can pop it to landscape. A short name and a description and what kind of language you're expecting this to be used in. This down here looks like a lot of information, but this is actually the entire web app manifest here in very short, sort of 10 lines. It's not a lot. Below line 10 and beyond is just the different size icons that you can be using for different size screens. You don't have to include this if you are only running for one particular device, but it's always good to include it if you want it to run on many devices. Once you've done that, if you hop into your HTML, if you're using a framework, you might have to look up how that will work for each different framework. I've tried this with Vue and React, and it's very simple. It's just adding a short script at the top of the React or Vue. So in Vue, that you'll add it just normally in the scripts on the mount. And it will run straight away. And what this does is it just imports the service worker. So from line 7 to line 14, you can see here, it imports this service worker and the web app manifest. And this will bring it into your main application so that everything should be running well. So if we take a look at what this service worker is, this is the last piece of the puzzle, the last thing we need to make it run offline is, again, this service worker doesn't need any modifications. You can find this code very easily with a quick Google search about progressive web apps or getting my application to run offline or just the word service worker. Or again, you're welcome to use mine, which will be attached to the QR code at the end. So this service worker here, we won't go over it. It just runs a couple of short functions to be able to cache the data so that it can run offline from the moment you load the page. That's it for the code. Try not to be overwhelmed by it. It is just 2 very small pieces of code that you can just add in as one as a JSON file and one as a JS file, and then just link them into the HTML. It's very easy to look up. There's a couple of Medium articles on this. You're welcome to use mine, as I said at the end. You don't really need to edit it too much, just in the web app manifest. If you want to change some of the styling or the name of your application, you shouldn't need to edit the service worker, but that might depend on whether you have a very large application. But for very simple ones, you shouldn't need to edit it. Once you've just added these, you should be able to run this application offline and you should be able to install it. And that's kind of all you need to make a web app into a installable offline web app, which is some of the criteria for making a progressive web app. That alone doesn't make it a progressive web app. As we discussed before, it will need to be fast, reliable, installable, which is what we just went over, and also work across many devices. That's something you should be doing anyway if you want your application to run both on mobile and desktop. So what makes a good progressive web app? It starts fast, it stays fast. It works in any browser. This is kind of key to getting it to work on all the other devices. If I'm opening it in a different screen size, it obviously has to load and work in that screen size, and it has to be able to work in any browser. So Internet Explorer, Chrome, Firefox, Safari, many others I probably don't know or forgotten. It has to be able to work in all of them. Otherwise, it's not really a progressive web app. You've just made a web app for one particular browser. So it has to be responsive to any screen size. I think I just went over that. And it has to provide a custom offline page. That is what we just went over in the code. So if you want to look at the web app manifest, the custom offline page there is showing the sort of styles and what will appear before the code is fully loaded. And last but not least, it has to be installable. If you cannot install the web app, then it won't work offline. And then if it's not a progressive web app, you just have a web application. So I'd like to thank you all for listening. My website is linked in the code on the bottom right. and the GitHub repository is linked in the bottom left. In the GitHub repository, you will have access to not only the website that I was looking at just now. So if we move across, you'll have access to this website. You'll be able to use the application. You'll be able to test it with Lighthouse and get sort of used to those things. You will also be able to play with the application if you like. I assure you, finding the day that you were born, interesting the first time, not so fun the second time. What else you'll have access to on the GitHub repository is you'll have access to this code. So if you couldn't follow along just now looking at the code, you will have access to that code. You can just fork or clone and download that from GitHub. I'm hoping you know how to use GitHub. If not, you can just view the code directly on the website and you'll be able to copy and paste from there. I'm fully happy with you stealing my code. And if you go over to my website, you'll be able to find many more applications, many more progressive web applications and other applications that you might find an interest in. Maybe you want to start to use them. You'll also find a copy of my CV if you are interested in contacting me at any point in the future. And again, thank you for listening, and back over to Jan.
Yay! Thank you so much. Wonderful. So let me share my screen. Thank you so much, Sean. That was wonderful.
Sorry. Yeah, yeah, sorry, it was my first solo one. So as you can imagine, it was a bit kind of, yes.
That was a lot of information that you had to cover. I mean, progressive web apps are not an easy thing, certainly, to learn and do.
Yeah.
How was it after? So you were interested before Code Chrysalis, and then during it, like, how was it creating this tech talk?
I had made that application beforehand. I made it progressive web application beforehand, and so I decided to use that. So it was nice that I already had a couple lined up ready to use. But to actually think about how to explain that to someone else is very different. So I had to remove a lot of the code to get the kind of things to show up. And I kind of wanted it so that you could access it and use my code as I was saying. So I needed to make it as simple as possible, but without removing the kind of functionality behind it. I didn't want to remove everything so I could go over it all. So it was quite a bit to get it set up. But I'm hoping that if you are interested, you'll head over to one of those two links and you'll be able to just get started by yourself. And I promise you, if you just spend maybe 10, 15 minutes, just download it, play with it, go through the Lighthouse. It's very easy to get set up. Although it's intimidating to start with a new technology, this one is very easy. It won't take too long.
Okay. Do you think you can share your screen actually one more time so that everyone can get the links and whatnot?
Yeah.
You should be able to steal it from me.
Sorry, yeah. So yeah, again, if you can go straight to the repository from the left-hand side one, but on the right-hand side, it has a link back to that repository anyway, but also some other applications and progressive web apps. So if you don't like my date of birth application, or you just want a second look from a second angle or what else it might look like, one with more code implemented, on the website, it has a couple more listed on there under the projects. It's on the first page. You don't need to tab around. It's just first thing that comes up is the projects. So it's very easy to find your way through.
Cool. Yeah, thank you once again. So yeah, everyone go check out the GitHub repositories and Sean's website. One of the best ways to just like get your feet a little wet with coding after you've learned a little bit how to code is just to see another project and see how someone's done it, tear it apart, play around with it, make changes. And so thank you so much, Sean, for providing a repository for people to have that experience, especially those interested in building progressive web apps, because that really is where tech is moving, where we're moving to. Thank you. So I'm going to steal the screen back from you.
There we go.
And next up, so in about 5 minutes, actually, we've got a speaker named Austin coming to talk about encryption. And so, yeah, this is starting in about 5 minutes. for Big MiniConf. If you're interested, by the way, in other topics, at the same time as this, we have Yuta on track A talking about Unity and machine learning. So if you go and go back to our event pages, you'll be able to find links to both of those. And this is currently getting live streamed to YouTube. So we actually have 2 YouTube channels set up, so you can see this stuff. Those are going to be, this is all getting recorded. So we will also have this available in the future if you want to go back and, listen to Sean talk about PWAs again. Maybe you missed certain bits of it. Maybe you missed another speaker. Go and check those out. Once again, like everyone speaking today, this is their first time giving a tech talk on their own in public about a topic that, frankly, we don't really teach at Code Chrysalis. And that's exactly where we want our students to be, especially, a little bit more than halfway through the course. We want them to be, learning stuff that that we don't cover in the course because, after they graduate, that's going to be their life. So it's really great to get to see everyone really starting to branch out and figure out what they're interested in and what they like. Or for cases like Sean, just continue checking out, the stuff that they were already interested in from before. So once again, we're going to have Austin talk about encryption in about 3 minutes now. So what I'm going to do is take a break and I'll be right back with you and Austin at 3:30 in about 2-ish minutes. Thanks. Hey, Sean. Oh, sorry, not Sean. Austin. Hey.
Hello.
How are you?
I'm good. How are you?
All right. I'm doing really well. Let's get you to share your screen and then we can be right on time with starting at 1:30.
Okay.
I say 30. I said 3:30, I think, before. I meant 1:30.
Okay.
13:30.
Give me a moment. Is my screen visible?
Yes, it is. So yeah, if you could get everything ready.
Okay. Yeah, everything seems ready to me.
Great. So yeah, you can get started in we'll get started in about 1 minute. So everyone, thank you for joining us. For those of you who are here, welcome to track B. Austin is going to be talking about encryption. We're going to get started very, very soon. Let me check out the time, make sure we're good. Austin, why did you choose encryption?
Why did I choose encryption?
Yeah.
Actually, I was talking about it to my friend one day about like how so I was talking to him about how one of my passwords got hacked, basically, because one of their databases got leaked and then they stored their passwords in plain text. And then we just got into this like heated argument about like whether salting your password even made a difference when it came to caching algorithms. And then we were just like, no, you're wrong. No, you're wrong. So I ended up learning quite a bit about encryption just through like natural conversation. But I think it's an interesting academic topic overall. Yeah.
Cool. Well, yeah, you want to get started with the talk?
Yeah, sure.
Yeah. All right. Yeah, take it away.
Okay, guys. So I'm Austin. I'm here to talk to you guys about encryption. As we all know, it is the bee's knees. It's a very interesting topic. I like it a lot. I suggest you guys read about it. But before I get into that, I'm going to talk about myself for a little bit. So my name is Austin Huang. Currently 22 years old and living in Tokyo. I was actually born in Vancouver, Canada, and I spent like 8 years in Shanghai and about 8 years in the States as well. So I'm bilingual in both languages, and I'm hoping to pick up my third here in Tokyo. I recently graduated from the University of Virginia, and there I majored in chemistry. As noted before, I am particularly passionate about encryption. I think it's really cool how they do it. And I think it's really interesting, like the math behind it. So let's dive right into what encryption is. So what is encryption exactly? Well, it is just a technique to protect and secure sensitive information. And so that information can be anything from bank details to passwords to where you were just yesterday. There are all sorts of methods and algorithms that we use to encrypt sensitive information. Those are usually called like either cipher blocks or algorithms. Yeah, it's pretty cool. In the current day, we use something called a mathematical key. So basically, it's just this huge prime number that we're going to use to encrypt and decrypt our information with. Yeah, the math behind it is very complicated, but it's very cool. And lastly, I'm going to talk about a very simple version of encryption that was done in the past. And it's a very famous example called the Caesar cipher. So what is the Caesar cipher? Well, Caesar's cipher is what Julius Caesar used to protect his messages from other people. So what he would do is that he would take any letter that he was writing in his message, so like A, for example, and he would push it back. Oh, he would, like D, for example, sorry. That he would take this letter, D, for example, and he would push it back 3 letters to become A. And he would just do that for his entire message. So for example, in this plain text message, the quick brown fox jumps over the lazy dog, you can see that he just simply pushed this T back to the Q. And he did this for every single letter, and he came up with this gibberish down here. So if some nefarious wrongdoer came across Caesar's message, they would be unable to understand what Caesar was trying to say. And this is just one of the most simplest forms of encryption. But we can see how there's a very big problem. It's that if the wrongdoer knew that Caesar was just pushing it back 3 letters back, then they would easily be able to decrypt this cipher text. So how do we do cryptography in the modern day? Well, there are actually 2 different ways that we use, 2 big categories that we put cryptography under. The first is called symmetric cryptography, also known as private key encryption. And the second is known as asymmetric cryptography, also known as public key encryption. And I'm going to talk about symmetric key cryptography first, because it's a lot simpler and very similar to Caesar's cipher, actually. So what is symmetric key cryptography? Well, it's when we use the same key to encrypt and decrypt our sensitive information. So I'm going to give you guys a very simple example now. So here we have Bob, or just anybody, and he's sending Alice a message. And in this message, he just says, hello, Alice. He's a very neutral type of person. And he takes this key, let's call it A, and he uses it to encrypt his message. And now it becomes this gibberish that no one can read. And he sends this gibberish to Alice, he uses the same exact key, A, and decrypts this message and is able to receive hello, Alice. And she thinks, oh, how boring. So these 2 keys in industry are known as private keys because we want to keep it secret from others. Because if everybody else had this key, well, then none of our messages would be very private now, would it? So if you were listening, you would probably think, wow, there are some key issues with this example. The first being that, how do we exchange the key? The second being, how do we manage the key if we had a lot of people in our group conversation? And the third is this very industry, this commonly used term in industry called key exhaustion, which is when we encrypt too much data using the same key. And I'll go into further detail in the next few slides. So in this first problem, the key exchange problem, what we're really thinking about is how do we have a secure channel to send my private key to someone else? And in real life, we might think of it as doing something like whispering to someone. So let's say I have someone in my class or someone in my office that I want to tell them my password. I could whisper to them, hey, my password is this, and they would know how to access my account. But there's a very big problem with that, and it's quite obvious, is that what if someone was eavesdropping on us? Then they would have access to my account as well, and they could leak that password to everybody else in the room. The second problem is, let's say all of us want to use some account. So all of us want to share an account, or all of us want to be in a group chat and have our data encrypted. Well, how do we share this password to everybody? And as the number of the users increases, wouldn't it be increasingly difficult to keep this password secret? And the last problem is, what if we stored too much information under one key? And so we can think about like Amazon, for example, who probably has terabytes upon terabytes of data stored in their servers. And a lot of that is quite private data. And if you imagine, if they use only one key to encrypt all that information, if someone were able to hack and decrypt that information, they would basically get all the information. And that's basically like putting all your eggs in one basket. And that's not very good. And that's what we call key exhaustion. And so if you want to get into more detail about this, you will learn that there is something called a key rotation, where they rotate their keys every month or so to prevent hackers from getting in. And they also do this thing where they only encrypt so much data under one key to prevent, leaking one key and having everything being stolen. And if you're more interested, I encourage you to read more about it, but it's a bit too academic for this presentation. So why do we even use symmetric cryptography when there are so many issues? Well, the biggest reason why we use symmetric cryptography is that it has good performance. If we want to encrypt our data and we want to encrypt a lot of data, symmetric cryptography is the way to go. And it's simply just a matter of when we use asymmetric cryptography, it is magnitude slower. And when it comes to small amounts of data, it doesn't really matter. But if we're talking about terabytes upon terabytes of data, then it really, really adds up. So that's basically it. So where do we use symmetric cryptography in our daily lives? Well, as developers, we probably have used something called bcrypt. And I know for me, at least, when I started using bcrypt, I kind of just said, okay, this is some cool hashing algorithm. I'm just going to use it and then call it a day. But the inner workings of bcrypt are actually quite interesting. But before we get into that, let's talk about why do we even use symmetric cryptography for password storage. And the biggest reason why, and the first reason why, is that we never have to share this key with anybody. We only have to store it in our server, and we just generate it once and we use it from there on. We never have to tell anybody our key except hold it to ourselves. Second is that we're not actually encrypting a lot of data. Remember, a password is only like maybe 16 characters long, and that's not a lot of data. So we will never run into the key exhaustion problem. And finally, there's no key management problem because we're not sharing the key again with nobody else. So how does bcrypt work? I know a lot of you people are wondering that and having sleepless nights thinking about bcrypt. But before we can understand how bcrypt works, we got to understand what a hashing algorithm is. I know you're thinking, hashing algorithm? What is that? Well, a hashing algorithm is just a way to turn a plain text password like this into some hash or some type of gibberish that nobody can read like this. And the reason why we do this is that, let's say a hacker were able to access our database. And if our passwords were stored in only plain text, then they would have gotten everybody's passwords. But if they were stored in a hash, then they would only get a bunch of hashes, which is just useless gibberish. Now, a very apt analogy for how this process works is actually a cooking analogy. So let's pretend that we have a bag of potatoes and we run it through some form of hashing algorithm to give us hash browns. Now, the reason why I say this is a particularly apt analogy is because we can never go from the hash browns back to the potatoes. And so when the hacker hacks into our database and gets all these hash browns, he's thinking to himself, what were the potatoes used? And that's exactly what's going on. He gets these hashed passwords and he is unable to derive or decrypt those things into the original password. Now, if you're very, very apt in observation, you would have noticed, what if the hacker had the recipe to make these hash browns? What if they had the algorithm? Then couldn't they make some sort of a table? In industry, we call this a rainbow table. It's where we take all the possible combinations of passwords, and we create all the possible hashes. And so let's say we get a database of only hash passwords. What we can do is we just run a bunch of possible passwords, and we compare the final hashes to the hashes that we hacked. And so in this case, if our plain text password was hunter2, it would always give us this gibberish called gibberish2, and the hacker would be able to say, oh, I see gibberish2, I know it's hunter2 then. Now, going back to the analogy, we can realize that we can do something to our recipe to make it random. So when we cook hash browns, the first step is to take our potatoes, right? But we also add a little bit of salt. And finally, we come up with the final product, the hash browns. Now, I don't know about you, but when I'm cooking, I don't always add the same amount of salt. It is a variable, you know, sometimes it's a little salty, sometimes it's a little not. And the same thing happens in a hashing algorithm. What we do is we add some small random bit of data, in this case, we call it a salt, to our original password. We run it through the same hashing algorithm, giving us a random result every time. And so what happens is that the hacker is unable to figure out your password just from the salted gibberish at the very end. Now, the reason why my friend and I had an argument about this earlier is because as computing power has increased, it's actually still possible to get your password. That's how strong computers are these days. So why do we use bcrypt then? Well, the thing about bcrypt is that it is very, very slow when it comes to encryption and decryption. The same amount of time, and when it comes to encryption. So let's say we have a very standard hashing algorithm, something like MD5, and we can probably hash passwords, hash a password in like 0.001 seconds, something like that. But maybe hashing the same password using bcrypt will take us about 2 seconds. So you can think about that as almost an order of 3 magnitudes, 3 or 4 magnitudes, in fact. And so putting that into perspective, a hacker who wants to brute force through all the combinations, through a bunch of passwords which were hashed using a typical hashing function like MD5, could check about 140,000 passwords a second. But if they wanted to check passwords that were encrypted using bcrypt, they can only check about 450. And when you think about that, that really adds up over time. So with the millions and millions and trillions of combinations that you can check, obviously only being able to check 450 would really slow you down. So now that I've gone into how symmetric cryptography works and a really interesting example of symmetric cryptography, let's talk about asymmetric cryptography. So in asymmetric key cryptography, there is only one key difference. The first, and it's just the sender and the receiver have a different key. We commonly refer to these two keys as one as the public key and one as the private key. The public key being distributed to the public and the private key being kept secret the whole time. Generally, we will use the public key to encrypt the message and we use the private key to decrypt the message. But its uses vary, and there's all sorts of ways to use this combination of keys. I'm going to give you guys a simple demonstration again, just to make it clear. So we have some secret data that we don't want anybody to know. And we're going to use the receiver's public key. So in this case, user2 is the receiver. And we're using user2's public key to encrypt our data. We send it to user2, and user2 uses their private key to decrypt that data and get that secret data back. Now, as you can see, this is completely protected for anybody else because the only key that can decrypt this data is the user2's private key. Again, the only key that can decrypt this data is this private key. So no one else can actually see this information. That's kind of cool. But there is a serious issue in asymmetric key cryptography called a man-in-the-middle attack. And that's when, instead of this public key, user2's public key, a man in the middle gives user1 their public key. And what ends up happening is the following. So in this example, we have Jack, who wants to communicate with Jill over here. But we have a nefarious wrongdoer called Peter, which is the man in the middle. So Jack tells Jill, hey, can you send over your key? I want to use it to encrypt my information. Jill says, okay, and sends her key to Jack, or so she thinks. Instead, what happened, Peter intercepts Jill's key and instead sends his own key to Jack. And Jack, none the wiser, encrypts his data using Peter's key and sends it to Jill. Peter then decrypts that information using his private key, changes the information, and re-encrypts it using Jill's key. Now he sends it back to Jill with the wrong message. And Jill sends money to the wrong account. And this is a very simple demonstration of the man-in-the-middle attack. And there are all sorts of variants to it, but that's the basic, most high-level version of what happens. So as we can see, there are some key issues with asymmetric key cryptography. First being the interception of the message, which is the man-in-the-middle attack. And second being the verification of the sender. So it's really, how do we verify that it is, Jack who wants to talk to Jill rather than someone else who wants to talk to Jill? And how do we verify that it's Jill who has sent the key rather than Peter, in this case, the man in the middle, who has sent the key? So I'm going to go into some examples to explain how we verify the sender. And in these examples, it will become obvious that, well, it should become clearer how we verify the sender. So the first example that I'm going to talk about is PGP encryption. And the second example I'm going to talk about is SSL encryption. Both of these are widely used forms of encryption that we will see every day, day in and day out in our lives. PGP, not so much. SSL, most definitely. So in PGP encryption, we have this diagram. And this diagram, it looks quite complicated, but I will break it down to you guys and make it quite simple. So the first step is understanding the setup that we need for PGP encryption. We need, first, a private symmetric key to encrypt and decrypt our data. Remember, if we have a lot of data, we want to use symmetric key cryptography. The second is we want to have an asymmetric key pair to encrypt our symmetric private key. Now, how does this work in practice? First, we have this data, and we're going to encrypt it using this private key right here. And so now we have some encrypted data at the bottom here. Our second step is we're going to take our public key here, and we're going to encrypt this private key that we use to encrypt our data. Third, we're going to send this data to whoever we need to send it to, and we're going to send this key along with it. So now we have this encrypted message with the data and the key being sent to the receiver. In the fourth step, the receiver will first decrypt the key using their private key. So now they have this private key over here. And finally, they will use this private key to decrypt the data, and now they have the data. And that's basically it. So now I'm going to talk about SSL encryption. Now, the cool thing about SSL encryption, and I'm not sure everybody knows this, is that it's actually what gives websites the S in HTTPS. So when we say S, we mean secured. And it really just means secured by SSL encryption. So it's used by like all the websites in the world. And the way they keep our website secure is through this process called certification. So they use something called SSL certificates to verify the senders. So I'm going to talk about what an SSL certificate is, why websites and why do people need them. And, just as a fun thing, let's talk about how to make one, because you actually never really have to make one. You just buy one or something like that. That's pretty cool. But to know how to make one is also just interesting in general. I think it's an interesting process, and it doesn't take long to explain. So let's talk about what an SSL certificate is. Well, it's basically just a way to digitally bind your organization's details to your key. So let's say you want to talk to Google, for example. And but you're not sure if you're talking to Google because anybody could pretend and say, hey, I'm Google. So what Google does instead is they get themselves a certificate that basically confirms that they're Google. So that when you grab their key, it will have something attached to it like this is certified and belongs to Google. Now it's a little bit of a high level sort of simplified explanation of what an SSL certificate is, but that's just the idea. So why do you need an SSL certificate? Well, as I mentioned before, anybody could pretend to be you as well. So let's say I want to talk to someone else and I send them something and they receive it and they're like, well, I can't know whose public key this is. How am I supposed to be able to trust to use this public key to send this information to my friend or to back, you know? And if I had some way to bind my identity to that key, then there would be no problem. And that's what an SSL certificate is. Of course, there's actually an interesting way where you use asymmetric key cryptography to do the same thing in essence, but it's a little bit more, it's a bit out of the scope of this presentation. So maybe look into it yourself. Let's talk about how to make your own SSL certificate just for fun. So you're gonna need to generate a private and public key. Remember, this is asymmetric key encryption. 2, you're gonna need to sign it. So you need to tell this information, you need to tell the group what you're doing. You need to tell this group, this key, who you are, basically. And lastly, you need to configure your website to use this SSL certificate. So first step is to generate your pair of keys. Now you can do this with some open source software. So there's this great website called OpenSSL. And when you go to it, you'll find that it's a project that basically wants to make encryption free for everybody. And so you can use that, you can go to the website and you can use their program to help them generate a pair of keys. So you would download it, install it, and you would type something like OpenSSL, generate some keys for me with some level of security. Afterwards, you're going to want to sign your certificate. And this is basically what it looks like. It's some form of form where you talk about, you know, where you're from, what your organization name is, what your name is, where to contact you, and so on and so forth. So in some other cases, actually, it's just a username and an email to contact you. But yeah, that's basically it. So this is the part where you bind your information to your pair of keys. And lastly, you just put it to your server, and that's it. You get the HTTPS over here. So if you guys want to know more about me, my GitHub is here. Thank you for listening. I hope you guys learned a lot from my tech talk.
Yay! That was great. Thank you so much, Austin. Yeah, just leave your screen up there a little bit for people who are on the live stream or in our webinar right now, so you can just get it. I'm really curious. So encryption for me has always been really tough. There's just so much to learn. When you were doing this, when you were trying to create this tech talk and doing the research, what did you feel like was like the hardest thing to wrap your head around? What was the hardest part of this?
I guess the hardest part of this would be trying not to go into the details and trying to go really in depth, because, you know, when I listen to a high level explanation, such as, you know, how do we bind a key to an organization securely? I think to myself, I want to know the details to this. I really want to get into, you know, how to do this process. And I think that was probably the most difficult part for me. It was not the high level understanding, but really wanting to get into the nitty gritty and like looking at the math and keeping myself away from that was actually quite challenging.
Sorry, forgot to unmute myself. Cool. Well, thank you so much, Austin. I'm going to steal the screen back from you.
Okay.
Give me a sec. Thank you so much. Once again, welcome everyone to track B of Big MiniConf. So Austin just talked about encryption. If you're here from track A and you somehow missed Austin's talk, don't worry about that. These are all recorded, so no worries. Next up, we're going to have Yuri talk about Dart. And after that, we have Jimmy talking about blockchain. So there's a lot of stuff happening. I also want to bring your attention to some Track A talks as well. So Track A, which is the other webinar, we've got Anime.js, webhooks, and Docker coming up. Again, don't worry if you want to be watching both at the same time. All of these are recorded and they're going to be on YouTube permanently. So don't worry about that. So far, really awesome talks. Everyone here is a first-time tech talk giver. So this is the first time that they're doing a tech talk that they have decided upon, researched, and put together on their own. This is the first time that they're doing it on their own. So really, really, I think nerve-wracking and scary. I remember my first tech talk. They're always, I think, terrifying to give. So I really hope that you give a round of applause, virtual applause, for all of our speakers for just getting out of their comfort zone and doing this. Next up, next up we have Yuri. But before that, I just want to bring your attention to some info. We've got upcoming immersives and foundations classes. So all the students right now are from our full-time, full-stack software engineering course, which is the immersive. And then if you don't know how to code, if you're interested, if you work at a tech company or work with other engineers and you just want to pick up a few things, go and check out our foundations class. It's our intro to coding course. So these are just some of the dates that I have up on the screen. And also, if you want to check out upcoming events, we are updating our meetup.com account all the time. That's where we put all of our events. All of our events are currently online. Not surprisingly, we hope one day that we'll be able to move them back into our awesome office. But right now, all of them will be online. And you can also follow us on Facebook, Twitter, Instagram at Code Chrysalis. And of course, we have our YouTube channel, youtube.com/c/Code Chrysalis. So up next, we have Yuri, who's going to be talking about Dart. Yuri, you there? Hi. Good to see you. Do you want to share your screen and then we can just get you set up and started? Uh-oh, I think your microphone is causing a little bit of some issues. Can you try to unmute yourself? Okay, great. Yuri, I think there's some issues with your microphone. And I can't hear you, so that makes perfect sense. Nope, still some issues. I can't hear. Technical difficulties. Yeah. No worries. Here, why don't you, while you figure that out, I'm gonna steal the screen from you, so that you can figure out what's going on there. Microphones are always very tricky. Uh-oh. Yeah, still can't hear you, but we're getting like feedback, so like white noise. So I think if you can take off your, yeah, I think that's what's causing the issue. Hello?
Hello?
Yay, perfect.
Okay. Great.
Yeah. Yuri, so you're going to be talking about Dart, and just before you get started, why did you choose Dart of all the languages and to learn?
So, I was actually looking at the list of the languages that there's the thing called like you should learn like 2020, and then Dart was one of it. There was all sorts of languages like Kotlin, Java, like all kinds. And then Dart was pretty new, and I was thinking, well, I want to learn something like really new. So I didn't know anything about Dart, but I just picked, and it turns well. So
Cool. Yeah. And you loved it so much you wanted to do a tech talk on it. That's great.
yeah.
So yeah, I'll let you get started. Go ahead and teach us all about Dart.
Sure. Okay. So can you see the screen? Okay. So hi everyone, and thank you, Yan. And I was really excited to be here today. So, and thank you all for coming. So for today's topic, I'm going to teach you how to play Dart. So the first thing that comes into your mind when you hear the Dart or darts, so it might be the game that you play that you can score. But the Dart that I'm going to talk about today is not the one, not that one, but something related to programming. And so let's get started. So first of all, I'm going to start off with a brief introduction of myself. So I am currently a Code Chrysalis student. And before coming here, I couldn't read a single line of code, and I just started coding this year. And now I am on week 8 of immersive course and learn Dart as my second programming language. I'm super surprised as myself. And also, by the way, I'm a big fan of ramen. So when I study abroad, I always miss ramen in Japan. And so let me know if you know any good ramen around, and I would love to try it. So here's today's agenda. First of all, I'm going to briefly talk about what is Dart, Dart, Flutter, or why Dart. And then the second, I will do a short demo with a thing called Dartpad. And third, I will show some apps that use Flutter. And the last will be my apps that I created during my Polyglot week. So first, what is Dart? So needless to say, Dart is a programming language. So Dart is a programming language that developed by Google. It is one of the fastest growing language inside Google, and is used by internal products like AdWords, Flutter, Fuchsia, Angular Dart, and so on. And outside of Google, companies like Adobe, Alibaba, the world's biggest marketplace, also are using this language in production. So when you're learning a new technology, in this case, a new language, you're going to invest a lot of time in it, right? And then you want to be very cautious about how it is right now, and then how it is going to be its future. Because the last thing that you want to see is that when you learn this, when you're spending months learning it, and then you don't want it to going out of industry. So, but for Dart, you can worry about everything else, but you will never worry about the development and maintenance of the language itself. And another feature of Dart is that Dart supports both Android and iOS, and even a thing called Fuchsia. So Fuchsia is also an operating system currently developing by Google, and it doesn't support Kotlin or Java, but Dart. And its user interface and apps are written with a framework called Flutter. So what is Flutter? I'm going to briefly talk about Flutter. So Flutter, first, it is an SDK. It is a software development kit that it is a collection of tools that are going to help you develop your applications, and it will compile them into native machine code. And so in this case, so if you have a frozen pizza, SDK is the oven for it. And another thing that Flutter is that it is a framework. It is a UI library based on a thing called widgets. So it is a collection of reusable UI elements. So this is widget. So like buttons, text inputs, sliders, and so on is widgets. Everything is widget in Flutter. And so you can personalize as you wish, like as you want to show on your app. So Flutter is relatively a new technology, but it gets more and more popular each day. And if you check the number of available Flutter jobs worldwide on LinkedIn, for example, you can see a lot of new jobs get posted each day. And more than 4,000 Flutter jobs available just on LinkedIn. Comparing to last year, it was only a few hundreds. So it comes to a question that why Dart? Why I picked Dart as my second language, and then why I'm suggesting you to do so. Other than the fact that Dart is backed by Google and it is used by Flutter, I will go over a couple reasons that you should learn Dart. So first, its flexibility. The Dart is a very flexible language that you can write your code and then run it anywhere, mostly anywhere without any limitations. So the apps written in Dart with Flutter are cross-platform native apps so that they can run on both Android and iOS. And you can even write web apps that code can compile so that code can run on any browser since it can be compiled to JavaScript. So for a developer, its flexibility is really important because you want to run your code on as many platforms as possible. And the second reason is that it is easy to learn. So the syntax itself is a mixture of Java, Java and C#. So a lot of developers says that you might already know Dart. So if you have some experience in language, it doesn't have to be some object-oriented language, but then you can already pretty productive in Dart within a couple weeks. I'm not saying that there's nothing new about Dart, but the new ideas introduced in Dart are very intuitive and it won't take that long to master. So the Dart syntax seems extremely familiar even at the first glance. And the last reason is that it is an open source. What's good to be an open source is that a good thing about open source is that instead of a small amount of people working on a project, you potentially have massive numbers. And also that you don't have to worry about all those licensing issues since Dart is open source from the beginning. And so that different from Java, that you don't have to worry like someone may sue you for using their language, or you have to pay anyone or company just for using it. Yeah. So far I've explained a couple reasons that why Dart is good overall, and I hope you have a bit of an interest in learning it. And next, I will do a short demo with a thing called Dartpad. So Dartpad is an online code editor for Dart language. And if you want to try Flutter, but don't want to set up all those development environment, Dartpad is very useful. So this Dartpad thing executes both Dart program and also Flutter. So Flutter program, so you can see its graphic output on it. So let me pull out Dartpad. So, okay, so this is what I call Dartpad, and hold on. This is Dartpad. So if you click on the right corner samples here, it got a lot of sample projects, and I will pick Sunflower. It seems very interesting. And so the left side would be the source code, and then the right side would be its output. So it will look exactly on your device. And if, for example, if you click on this pane keyword and click documentation here, one of the good things about Dartpad is that it will show the documentation right here, so you don't have to look it up. And another feature is that if you drag and resize the window here, you can see how it is going to look like on different devices. And the last feature about Dartpad is that it supports gist. So what gist is that it is so you can execute script online. So let me pull out a sample gist code here. And let me copy the ID here and into Dartpad. is running. Click run. So yeah, here's the sample, how the sample code shows, and it seems like it is a counter, so can be used for shopping app. What a good thing about this just is that so if you have a source code that you want to get feedback from customers and testers, you can just share this source code with them so that they don't have to set up all those development environment, but still can give you feedbacks. So far, I've briefly introduced about this start pattern. Let's write something on this on Dart. So I create a new pad, and let me delete this. So let's try to print hello world into console. I'm going to write. So what I'm doing here is that when it runs, it automatically looks for a main function. So you have to have a main function. So since Dart is a type language, you have to specify the type of this function. And since it doesn't return anything, so I write void, and main is the function name. So within that, I'm going to write print. So print and pass the hello world. If you click on print, it will show that what print is doing is they print a string representation of the object to the console. And if I run it, you will see hello world in the console. Okay, then next, let's try to let's try to show hello world into our actual Flutter app. So let me import Flutter. So I import a package here and write a function called run app. And what run app is doing that, it is taking widgets to the screen. So I'm going to pass it into this function so that it can print. Okay, when I run it, it's not going to show anything, but we don't see any errors. But it is because that Flutter wants to know whether the text direction, whether it is from left to right or right to left. So I'm going to specify the text direction. It's left to right. Okay. And if you run it, okay, there you go. So we see the left corner, there's hello world showed up. And if you want to put hello world into the middle of the app, I would just wrap it with center as its parent. If you run it, it has one error that shows too many positional argument. It is because the center only takes one child. So I have to specify its child. And if you run it, okay, then you see hello world in the center of the app. And this is the minimum app that you can make. And it only takes you 5 minutes. So also Dartpad has this formatting. So if I add some comment, it will automatically format for you. Yeah. So let's go back to my presentation. So far we've seen this Dartpad, and the next I will talk about who uses Dart, and we will take a look at how companies are using Flutter to make beautiful apps. So the first I will talk about is, so the first app that we got is Google Ads. So it is an app to promote your app. It is an online advertising platform developed by Google so that users can pay and promote their products and services on Google Search, YouTube, and all other sites across the web. And this is how their user interface looks like. So in the middle, it got the listing, and then the left is the overview, and right is your user account. And so users can manage multiple accounts from one login and dashboard. And the next one that I found very interesting is this smartphone app that called Insight Timer. So it is an online community for meditation. And so this is how the app looks like. So it got the timer for you to meditate and courses from by the teachers all over the world, and also got very soothing music for you to sleep. And the last app that I'm going to show is MGM Resorts. So if you've been to Las Vegas, you probably know MGM. It is a corporate that operate hotels like MGM Grand or Bellagio. And this is how the app looks like. So it got digital key in the middle, and in the middle, so that you can check in and check out contactlessly, and especially it is very useful during this time. And also with this app, you can reserve restaurants and check your status. So these are the amazing apps that use Dart with Flutter. And next, I'm going to show how my app looks like that I made during this week of Polyglotto. So first, I will do a short demo with it. So here is very simply, here is how my app looks like. It is an app whether you can draw or puzzle. So first, I will click draw, and so you can draw here, and then you can clear. And let me draw something here. Okay. And you can pick, gosh, this is not what I wanted, but it is actually really hard to draw with laptop. But yeah. I think I'm okay. Yeah. So like this, you can draw with this. Yeah, you can draw here. And so if I swipe back to the home and click puzzle, and in puzzle, whether you can choose to take a photo or pick a image from a gallery, since I'm using emulator, I won't be able to use camera, but let me pick from my gallery. Yeah, let me pick this one. So there will be I believe it's 9-piece puzzle up here, and you can just play the puzzle here. So let me try to solve this puzzle. And there you go. So yeah, this is what I made during my Polyglotto. And let's go back to my presentation. So for future, the functionality that I want to add for my app is that I would like to be able to save. Right now, the photos and the picture that you draw won't be cannot be saved into your local devices, but I will work on it. So the last thing that I'm going to talk about is the Polyglotto week that I just finished on Friday. As I mentioned before, I've never learned anything related to programming like before I joined Code Chrysalis, and it's just been week 8, and I've learned a new programming language within a week, and I'd be able to build an app with it. And I'm actually very impressed and surprised at what I'm capable of, and I'm very glad to have this opportunity to do so. So yeah, this is all from my presentation. And if you're interested in me, please scan the QR code of my GitHub. And thank you, Code Chrysalis, and thank you all for listening. And I hope you have a great day.
Yay! Way to go, Yuri. So it's cool that you showed off one of the apps that you made with Dart and Flutter. When you were learning how to do this, what do you think was the hardest part of learning? Because this is only your second language, right? So you started with JavaScript first because that's what our program is in. And then you just kind of chose Dart just because you were like, oh, it's a new language. I'll do that. When you're learning the second language, like what was the hardest part about this?
The hardest part was that it is actually quite different from JavaScript in some sense because it's typed, and I've never learned any typed language before, and I have to get used to it. And that was the hardest part. And also the concept called the widget in Flutter is also new, so that I have to get used to it. And then it's a pretty new language that you not like other language like C++, Java that has a lot of resources. So that was also difficult.
Yeah. I remember seeing on Twitter someone else mentioning that as well, like learning a second language. It's like JavaScript, we are lucky for JavaScript to have such a wide, wonderful community with tons of resources. And if you're learning a newer language like Dart or Rust, like that, it's just not there yet. It doesn't have like that. It needs to catch up with like a decade's worth of material. Well, cool. I love how you were able to build something in such a short amount of time. And I think that's what people often forget with like learning a second language, that if you learn the first language well, even though it took ages to learn JavaScript for everyone, right? Now, like picking up a second language, it's, you can do it in like a week. And have something up and going. So that's pretty cool. So thank you so much. I think next up we have, who do we have? We have Jimmy, who's going to be the last speaker for this track that we've got today. Let me share my screen real fast there. Cool. So Jimmy is going to be talking about blockchain, what it is, how it can help your business. And this is going to be the last talk on track B. For track A, after Jimmy is speaking, we've got Florian rounding out Big MiniConf to talk about Docker. And then that's it. If you missed any of the talks, don't worry, they are all online. We have all of the talks recorded, and they'll all be put onto our YouTube channel. Jimmy, hello. After Jimmy is talking, we've got one more on another track. And just a quick announcement for everyone. If you're here, if you have just learned about Code Chrysalis for the first time, we are a coding school, a coding boot camp based out of Tokyo, but all of our classes are also available online. And all of the people that you're seeing today, they are our immersive boot camp students. So Jimmy, who's right here right now, and Yuri, who just spoke, and Austin and Sean, they are currently a little bit more than halfway through the course. Like they've got another third of the class left before they graduate. So these talks are done while they're going through the course. We ask everyone to choose a topic that that they're interested in. They get to choose what they want to do, and they put together a talk. And what's cool is, I think, everyone everyone giving a talk right now chose stuff that we don't cover at all at Code Chrysalis. And that's exactly where we want people to be, like getting comfortable, feeling confident with just learning something completely new that we don't touch upon at all. If you like this, if you want to check out some more events, we've got events on our meetup page, so meetup.com/code chrysalis. And you can also, of course, follow us on Facebook, Instagram, and Twitter. We try to keep those updated. And all of this stuff, and also the previous mini-confs that we've done. So our previous graduates who are now alums out in the world, you can see all of that on our YouTube channel. If you are watching this on the live stream, this is our extra channel because YouTube doesn't allow multiple streams to the same channel. YouTube, please fix that. Anyhow, this is our extra channel so that we can do these two streams at the same time. Everything that we're going to have here, we are also putting onto our main YouTube page. So go and check that out. That's also where all of our other recordings are. And so Sean, you're going to be talking about, or sorry, why am I saying Sean? Jimmy, you're going to be talking about blockchain today.
Yes.
Why blockchain? Like, what got you interested in it?
Well, I suppose first of all, it was kind of due to a little bit of the big boom of Bitcoin all the way back in 2017, a whole like 3 years ago. But yeah, no, it's always sort of interested me, like how that was all hosted and things like that. So
cool. Jimmy, do you own Bitcoin?
I do not, but after doing this talk, I really want to.
Do you like own any cryptocurrencies or anything like that?
No, I want to get into Ether and Ripple though, so that would be pretty cool. Yeah.
Yeah. So yeah, blockchain is a huge buzzword still, and I think it's cool getting, seeing how many different ways it can be, applied to different problems and challenges we have in the world. And so this is what your talk is going to be on. Also, just before I let Jimmy continue speaking, we've got 2 events coming up. So Jimmy actually is going to be graduating from our boot camp at the end of next month. So September 24th, get your calendar ready for that. That's going to be demo day. So everyone is going to be showing off the senior projects that they're working on. Actually, they haven't started yet. You guys haven't started that yet, but you will be choosing, but they will be coming up with some cool senior projects. No pressure to think of something awesome and unique and challenging. And so whatever those are going to be, we're going to find out, and they're going to be presenting them September 24th. It's going to be online. Also, the day after is the junior class. So the class that just started the immersive will be doing an API night with Stripe, actually. So we've got like kind of a really jam-packed end of September there with 2 really big events that we have. And also for all of you watching this stream today, we are offering 15% off our foundations course. This is a summer coronavirus special. It's only lasting until August 31st. So sign up now. You can have the 15% be for a course in the future that's happening after August 31st, but sign up to get that. Sign up before the 31st to get that discount. So Jimmy, I think we are almost ready. Do you want to share your screen and we can get going?
Yes, I'll get started on that.
How can blockchain help our business?
Exactly.
Yeah.
Tune in to find out how.
Yeah. Great. All right, take it away, Jimmy.
Sorry. Okay, so yeah, thank you, Yan. Hello, everyone. So my name is Jimmy Wilson. Today, I'm going to dive into something that I've always been interested in, but never really knew that much about. So what is blockchain and how can it help your business? So first, a little bit about me.
My name is Jimmy Wilson. I'm from New Zealand, more specifically a quiet little beach town in the North Island called Tauranga. It's a really great place to grow up and has an amazing beach and quite nice weather. I'm 28 years old, and yes, because I'm from New Zealand, I know how to do the haka. For those of you who don't know, it's the Māori war dance or challenge, which is commonly done by the New Zealand rugby team, the All Blacks, before every game. So I used to work in IT recruitment for almost 2 years, which was my first real exposure to this amazing industry of IT. I became really jealous of the people that I was interviewing. They, of course, were focused on technology and software, but with a real emphasis on how it can really help people and businesses out in order to make life easier. So I joined Code Chrysalis in an effort to become one myself, which sort of naturally led me into my topic of this talk. So what exactly is blockchain? Like I mentioned before, most people associate it with cryptocurrencies such as Bitcoin. And I'm sure many of you heard about the absolutely massive boom of Bitcoin back in 2017. Well, blockchain is the platform that cryptocurrencies use. So at its core, blockchain is essentially a bunch of blocks connected by a chain. That's it. Thank you very much for coming to my talk. I really appreciate your time. No, only kidding. Still heaps to go through. So in its essence, blockchain is described as a distributed, decentralized public ledger. Think of it as I explained before, but the block is just digital information and the chain is the public database in which it's hosted. So for those of you who may need a little refresher for what a ledger is, well, a ledger is the thing that is used for recording and totaling economic transactions. To get into the nitty-gritty definition, this is usually measured in terms of monetary units like yen or dollars, of account by account type with debits and credits in separate columns, also showing a beginning monetary balance and an ending monetary balance for each account. So in a nutshell, a record of bank transactions. So you might be thinking, who owns all this? There has to be someone who owns and distributes blockchain, similar to how we use a bank's services. Well, the easy answer to that is no one and everyone. The creator of Bitcoin is someone named Satoshi Nakamoto. Who is Satoshi Nakamoto? Well, that's another crazy thing. No one knows. Could be a group of people, a man, a woman, an alien. Yeah, no one really knows. So no one really knows who owns this blockchain technology. Although specific and individual blockchains can be owned by different organizations. This is kind of how you can own a blockchain application, but you cannot technically own the technology itself. Many organizations are developing their own private blockchain, therefore becoming owners of it. But the concept of owning a blockchain is very different from owning blockchain technology. It relies heavily on third-party involvement, where people verify blocks and are rewarded for doing so, which leads to my next point, decentralization. This means that it's finally something that Bill Gates doesn't own. Let's have an example, a real life example, which involves, let's say I have money, like heaps and heaps and heaps of money, like a whole $5. I decide to give my $5 away because of reasons, so I no longer have my $5 anymore. But now let's say our great MC Yan comes along with something really, really cool that I want. I decide to pull a sneaky and I say, hey, I have $5. Can I have that? Yan can then use the decentralized ledger and look to see the transactions that end up showing the fact that I don't actually have my $5 anymore. So instead of making that sweet deal of me, which I mentioned, only to find out later that I don't have the $5, she can simply check out the decentralized ledger to see that I don't have what I said I had. Unfortunately, this sometimes happens with some companies out there. They end up being guilty of doing deals with means that they don't actually have. So decentralization stops this. It's a pretty cool idea, right? So back to the blocks. The cool thing about these blocks is that it stores information like date, time, digital information, and or dollar amounts of your most recent deployment or transaction. Blocks store information about who is participating. But if you're worried about things like privacy, instead of using your actual name, it's recorded without any identifying information by using a digital signature, sort of like a username. So much like you and I have names to distinguish us from one another, each block has its own unique code called a hash. And this allows us to tell it apart from every other block in the chain. Hashes are cryptographic codes created by special algorithms. So even though you might have the exact same information in each block, for example, it could be the same time, same date, everything's the same, you can tell the differences between them by this cryptographic code or hash. Another thing is that these blocks are immutable, which means they cannot be changed. They're actually stored across many computers in a peer-to-peer network. So in doing so, it is actually programmed that any block within the chain cannot be altered retroactively without the alteration of all subsequent blocks. So because it's in everyone's best interest not to change their blocks, this keeps it secure and also allows the participants to verify and audit transactions independently and also relatively cheaply. The use of blockchain takes away characteristics such as duplicate transactions. So what it does is it confirms that each unit of value was transferred only once, and it solves the long-standing problem of double spending. And lastly, by storing data across its peer-to-peer network, the blockchain eliminates a number of risks that come with data being held and controlled centrally by one organization. So now I'd really like to talk about some of the main uses of blockchain. In its essence, blockchain is a value exchange protocol. So onto the first and most common use, which everyone is quite familiar with, of course, making payments with cryptocurrency. For example, using Bitcoin and other cryptocurrencies to buy things. So there are two widely known blockchain networks, the Bitcoin network and also Ethereum, which I will be diving into a bit more later on. So these have currencies using these networks as a host. So the Bitcoin has the Bitcoin network has Bitcoin, Ethereum has Ether, and that's just one example. This is all stored in what's called a Bitcoin wallet, or just simply a wallet. It's kind of like a digital wallet that you can think of your computer as a wallet, and you can go in there and grab money out of it. Yeah. So the next use, which actually really surprised me, is improving marketing campaigns. So how is this possible? As the blocks can be used to store unmutable data, blockchain can be used by marketers to keep track of client information and consumer behavior. For example, any changes made to campaigns or other things such as media releases during development can also be easily identified through searching the public ledger. So if you encounter a mistake down the road, you can use the blockchain technology to find out who made it and when. Another great example is that blockchain allows marketers to verify the traffic that they attract is from real people and not bots. When your marketing stats are not overrun with bots, you get a much better and accurate reading on statistics, so money spent on marketing can be more cost effective, and this is the whole verification side of every block. And lastly, and the topic that I'm going to dive into a bit more is smart contracts. This really interested me looking from the outside in. I can really see the appeal for businesses to use this technology. Some of the benefits that I researched include saving money by cutting out middlemen and also being more secure, as both parties using blockchain technology for contracts makes for a secure transaction that cannot be changed. The programmable function is used to hold everything and release both items of value to both parties respectively when the date arrives. And if not, and the conditions are not met, then the refund is issued. These can also be used for digital information exchanges also, with digital information being stored and released respectively. So it doesn't only have to be used for cryptocurrencies. By utilizing smart contracts, you will never have to worry about late payments for exchanges, as they are released to both parties at the same time. And if one side decides to skip out and not hold up their end of the bargain, the condition of the function is not met and the refund is issued. So if you didn't quite catch that, no worries. I'm going to go into an example test case to help explain what is happening. So this is Mary, and she wants to have her house cleaned. She wants to make sure that this is done effectively and efficiently, while also at a good price. She is the client. This is John. He's a house cleaner. He really wants to make sure he is paid for the work that he does. So because he does the work, he is the tasker. So Mary is the client, John is the tasker. They decide to set up a smart contract on the blockchain marketplace, and Mary specifies the task and the agreed amount of cryptocurrency to pay. So they decide to set up the smart contract, and Mary specifies the task, the agreed amount of cryptocurrency, and the platform creates a smart contract with the client's and the tasker's public wallet address. Then Mary sends the money to the smart contract with a very, very small transaction fee. So this transaction fee is called gas. And basically what it is it's a tiny amount of ether used, or cryptocurrency used as a payment in the peer-to-peer network. So this is for when people go through and they mine blocks, which is another way of saying that they go and secure and verify every single block. And then this gas gets paid to the miner. So the tasker, John, then completes the cleaning for Mary, after which he notifies the contract that he has completed the job. Well done, John. If Mary confirms that the job is done, the smart contract will automatically transfer the money over to John. Everyone's happy. But if Mary confirms that her house has not been cleaned, then the condition is not met and the money will be transferred back to her. So what are the benefits to both parties? So the first benefit is there are no intermediaries. They are not needed as the smart contract is executed automatically. The contract is immutable, so it can't be tampered with, and it's also transparent. So like in my previous $5 example, John knows that Mary has the cash to pay him. The transaction fee is also very low compared to traditional payment systems. What I mentioned before with gas, it only equates to about maybe 1 to 10 yen or 1 to 10 cents, sorry. So it's very, very cheap. And finally, the smart contract is executed quickly and independently of any traditional financial institution. So before getting into the outcome of testing my contract, here is the code. So this was written in a programming language called Solidity, which is used for Ethereum. For those of you who are software engineers, it's a little bit like JavaScript, but you will need to specify data types throughout the code. So without further ado, here is the contract that I made, of course, with a lot of help from online tutorials. Here it is. Fantastic. And moving right along. Oh, what was that? You want to see it again? Ah, it's great, isn't it? So I know what some of you might be thinking. Did you do TDD? Did you write tests? The answer is yes. So there's this testing library called Truffle. It's used to test contracts in Solidity. So here's the small amount of code, which of course, once again, was helped out by online tutorials. So here's the code, just a very small amount of tests, as you can see, just ever so small. Wow. Yes. Thank you very much. So, but in all seriousness, I will link to my GitHub repository at the end of this talk, but we will get there soon as I still have to go through my findings and the outcomes. So, on to the outcomes. Well, it managed to work, and it worked out fine and good. And this was after getting used to what's called Remix. Remix is an open source tool that helps you write Solidity contracts straight from your browser. Think of it like a test blockchain where you get set up with test wallets and test ether. You can make smart contracts and deploy them to the fake Ethereum blockchain. So I did a test case to complete the task, and it completed the task. And then I did a test case to fail the task, and it sent the refund. So everything worked out great, which was quite nice because this was my first time trying to implement something like this. It was quite simple, but I think my code could definitely be made more secure and improved upon to have more functionalities. But for this test case, I think it works just fine. So do I recommend this for businesses? Well, I'll put this in the way that most software developers answer any question when they get asked. It depends. As I mentioned, this was a very simple example. I think it could definitely be improved upon and used for lots of different cases. For this reason, I think it's really great as well, if both parties are using blockchain already. In order to do a contract with someone to exchange cryptocurrency, you of course would need wallets. Both parties would need wallets. And if one party isn't using blockchain, unless you force them to do so, smart contracts are actually kind of redundant. So for the average small company that is not technical or doesn't have software engineers in-house, I've come to the conclusion that it might not actually be the best thing. This is because you would either need to use a third party that manages all the contracts or hire technical staff members in-house to do this for you. However, if you are an IT startup, if you spend a bit more time on the initial research and how to implement it, smart contracts may be a great idea to have lying around. You have a whole bunch of engineers anyway. Why not try something new that could potentially save your business money in the long run? Once you have a smart contract made, you may only need to make small changes for each time it is deployed. This can be extremely cost effective and also very, very simple. So on to big companies. I'm going to do this with an example of a French tourism holding company, AXA. And most people know them for insurance. They actually built a smart contract named Fizzy a couple of years ago for automatic compensation for flight delays. So for the passenger, this system takes a small fee and some necessary personal information to prove that the flight has been taken, but pays out the refunded insurance in case a flight is delayed by 2 hours or more. So unfortunately, AXA actually had to stop early this year due to struggling and reaching commercial targets. So they said right now, the market appetite isn't quite hungry enough for a blockchain-based consumer insurance product yet. This also points to the wider issue of adoption in the blockchain industry. Like my previous point about more people adopting blockchain as a viable payment or contract system. However, AXA has said that they will continue to test these types of innovative products and has gained valuable experience in building, funding, and deploying smart contracts on the Ethereum network. So the more it grows, the more prepared they will be to try again, which looks really, really good for the future. So in all, I think blockchain is pretty cool, especially the smart contracts. There are definitely practical uses within businesses, and the more people start using it, the better it will become. Being a distributed, decentralized public ledger means it is secure and open to the public. The blocks are immutable and transparent, so cannot be changed or altered, and the transparency, for example, like my $5 example. When it comes to smart contracts, as long as you get someone to set them up initially and the training on how to implement it, I can see huge benefits for this. Cutting out the middleman can be cost effective, while also having more and more businesses getting into this makes having a smart contract to implement easily a great idea for the future. I see the benefits the more people get on board. So, thank you very much for listening to my presentation. I hope you enjoyed it and learned a bit more about how blockchain could potentially help your business by saving money and manpower in the long run. If you have any questions for me about any of this, I'm more than happy to answer any questions. You can find me on my LinkedIn under Jimmy Wilson. I think you could have the Jimmy Wilson code Chrysalis, and I think I might show up. Or on my Twitter and Instagram, it's all at Jimmy T. Wilson, and same as my GitHub. Here is a QR code to my GitHub where you can see my public repository for the smart contract I implemented. So please check it out, have a look, leave some comments, maybe tell me to do some improvements on some things. That would be really, really great. So thank you very much again, and I hope you enjoyed.
Yay! Thank you so much, Jimmy. So now that you've learned and done all this research on blockchain and whatnot, quick question before I wrap up track B. Is this something that you want to maybe continue finding a career in, like trying to be a blockchain developer?
That's a really good question. I think it's definitely, you know, like I said, the more and more people that get into it, it's definitely going to become a powerhouse. So I think it's right now, maybe not, but definitely in the future, I think it's something that I could continue working on and become, I mean, hopefully an expert, right?
Yeah. I think blockchain is definitely one of those technologies that we should all be keeping an eye on just because things change so much, right?
Yeah.
So yeah, thank you so much. I'm going to steal the screen back from you. Hello, everybody. Thank you so much for watching track B. Before I kind of switch things over to track A, please go and check out some of our other events. So Jimmy, who just finished speaking and talking about blockchain, is going to be actually graduating at the end of September. He's going to be showing off a really awesome, super unique, super cool, super tough web app that he hasn't built yet, but I bet it's going to be, it's going to be awesome, Jimmy. He's going to be showing that off along with his classmates on September 24th. And then after that, actually, your junior class, so the class right below you that just started is going to be doing their first public tech presentation. So they're going to be presenting still yet to be created projects done using Stripe.
Yeah, can't wait.
Yeah. And if you're interested in Code Chrysalis, if you don't know how to code and you just want to get your feet wet, we're offering 15% off of our foundations course. That is going to be available for only about 2 more days. So it's our special summer coronavirus discount. So apply now and get signed up before the end of the month, and you'll get 15% off of our classes. And once again, these are just some upcoming course dates that we've got. And you can check out our meetup.com for more events, as well as follow us on Facebook, Twitter, Instagram, all of that good stuff. You can also check out our very last speaker. So we've got one more coming up. You can check out track A. There's the link to it. And Florian actually is going to be rounding out our big MiniConf with a talk on Docker. So if you don't know what Docker is, or if you've heard about it, but you don't know very much about it, go and check that out. He'll be talking about containers, why they're useful, what we use them for. And so there's the link, on our other track, and that'll be it. So thank you all so much for listening. We had 4 really awesome speakers for this track, and I will see you on track A. Thank you all so much.